Hello my dear students, in the last class I explained about stresses on an oblique section of a body subjected to a direct stress in one plane and also in two mutually perpendicular directions. Today we will discuss stresses on an oblique section of a body subjected to a direct stress in one plane and accompanied by a simple shear stress. Okay, in the last class what we have studied means direct stress subjected to two mutual perpendicular directions, but here along there is a direct stress, along with that there is a simple shear stress also. We'll see how to find stresses in such type of cases. Okay, let us consider a rectangular body of uniform cross-sectional area and unit thickness subjected to a tensile stress along x-axis axis accompanied by a positive, that is clockwise, shear stress along x-axis axis as shown in the figure. See here, you can see here, this is an oblique section of the body AB. Okay, oblique section AB, and here this is the direct stress sigma x in x direction. Along with that there is an shear stress also acting in the x direction, tau xy. See here, you can see tau xy and tau xy. How stresses are developed in this case? This is stresses are developed like this, and here finally this is the normal stress and this is tangential or shear stress. Okay, it is as usual procedure. You have to derive that derivation you have to do. So let us consider sigma x is tensile stress along x-axis axis and tau xy, that is positive, clockwise direction is positive and anti-clockwise direction is negative shear stress along x-axis axis, and theta is angle which the oblique section AB makes with x-axis axis in clockwise direction. Okay, let us first consider the equilibrium of wedge ABC here. You consider this. Based on that, as the principle of simple shear, the face BC of the wedge will be subjected to an anti-clockwise shear stress that is equal to tau xy as shown in the figure B. Okay, tau xy here. Can see this, and then you resolve that equation along the horizontal force and also along vertical force and horizontal force acting on the face BC also. Okay, so you get this Px is equal to sigma x into AC and Py is equal to tau xy into AC and P is equal to tau xy into BC. So you have to simplify that this equation. So finally derivation is not so important, so you remember this final equation. Okay, this is important. You should know what is the equation, what is the formula to find normal stress, that is this one. Okay, sigma n is equal to sigma x divided by 2 minus sigma x divided by 2 into cos 2 theta minus tau xy sin 2 theta. Okay, this is for normal stress, and in addition to that you have to find shear stress or tangential stress. Again derivation you have to do the derive. Okay, so finally you get this equation, tau is equal to sigma x divided by 2 into sin 2 theta minus tau xy into cos 2 theta. Okay, after the derivation you get this final equation. This you remember to solve the problem. Okay, and here in addition to this normal stress and tangential stress, you have to find maximum principal stress also, that is sigma p into 1, sigma p1. Okay, that is this formula you have to remember. What is that? Sigma P1 is equal to sigma x divided by 2 plus square root of sigma x square divided by 2 plus tau square xy. Okay, this is maximum principal stress, and you have to find minimum principal stress also, that is sigma P2. Okay, so that is this equation. You have to remember this equation. Okay, that is sigma P2 minor principal stress is equal to sigma x divided by 2 minus tau into sigma x divided by 2 whole square plus tau square xy. Okay, so these four formulas you have to remember, then only you can solve the for numericals. Okay, let us consider one simple example. A plane element in a body is subjected to a tensile stress of 100 MPa accompanied by a shear stress of 25 MPa. Find the normal and shear stress on a plane inclined at an angle of 20 degree with the tensile stress and the maximum shear stress on the plane. Okay, this is the given example. You have to calculate the normal and shear stress and also maximum shear stress on the plane. Okay, so what is given here? Tensile stress along x axis, that is sigma x, that is equal to 100 MPa, and shear stress, that is 25 tau xy, is given 25 MPa. So angle is given, theta is 20 degrees. So you have to find normal and shear stress on the plane inclined at an angle 20 degree. How you can find? Let us use first normal stress formula. What is that? Sigma n is equal to sigma x divided by 2 minus sigma x divided by 2 into cos 2 theta minus tau xy sin 2 theta. Okay, substitute. What is sigma x? Sigma x is equal to 100 divided by 2 minus sigma x is 100 divided by 2 into cos of 2 theta. 2 into theta is 20 degree minus tau xy. What is tau xy? That is 25 MPa, 25 into sine 2 into 20 degree. Simplify this, you get normal stress on the plane, that is sigma n is equal to 4 minus 4.37 MPa. This is normal stress. Okay, then we'll find shear stress. How to calculate shear stress? Shear stress formula is tau is equal to sigma x divided by 2 into sine 2 theta minus tau xy cos 2 theta. Okay, what is sigma x? Sigma x is equal to 100 divided by 2 into sine into 2 into 20, theta is 20 degree, minus 25, tau xy is 25 into cos of 2 theta. Okay, simplify this, you get tau is equal to 12.99 MPa. Okay, what is next? You have to calculate, you have to find maximum shear stress on the plane. How to calculate maximum shear stress on the plane? That is equal to tau maximum is equal to square root of sigma x divided by 2 whole square plus tau square xy. Here you have to see the difference between the first two cases. In that it was direct square root of sigma n square plus tau square xy plus sigma sigma n square plus tau square, but here means square root of the resultant of normal stress square plus shear stress square, but here that is there is a difference. Tau maximum is equal to square root of sigma x divided by 2 whole square plus tau square xy. Okay, so what is sigma x? Sigma x is equal to 100 divided by 2 whole square plus 25 square. Simplify this, you get 55.9. So like this you can calculate what is normal stress, what is shear stress, and what is the maximum shear stress on the plane. Okay, I hope all of you understood. We'll take one more example and we'll see. Okay, what is that? Next is an element in a strained body is subjected to a tensile stress of 150 MPa and a shear stress of 50 MPa, tending to rotate the element in an anti-clockwise direction. Find the magnitude of the normal and shear stresses on a section inclined at 40 degree with the tensile stress, and the magnitude and direction of maximum shear stress that can exist on the element. Okay, here you have to find normal shear stress. Along that you have to calculate what is the magnitude and direction of shear stress also. Okay, what is given here? Tensile stress along the x-axis, that is sigma x, is equal to 150 MPa and shear stress tau xy, that is equal to 50 MPa, tending to rotate the element in an anticlockwise direction. So anticlockwise, that's why this is minus sign due to anticlockwise direction, and an angle made by the section with the tensile stress is equal to 40 degree. Okay, first let us find what is the first one. Normal stress on the section. Direct substitution. Okay, what is the formula? Sigma n is equal to sigma x divided by 2 minus sigma x divided by 2 into cos 2 theta minus tau xy into sin 2 theta. So here no need to explain. You have to direct substitute the values. You will get the answer. Okay, so sigma x is 150, substitute, theta is equal to 40 degree, substitute, and minus tau, minus already there, but tau xy is equal to minus 50, so substitute minus 50 into sine 2 into 40 degree. So simplify this, you get sigma n is equal to 111.222 22 MPa. Okay, so next we will calculate what is shear stress on the section. What is shear stress? Shear stress is equal to sigma x divided by 2 into sine 2 theta minus 2 tau xy into cos 2 theta. Okay, substitute here again tau xy is minus 50, so minus into minus 50. So simplify this, you get tau is equal to 82.54 MPa. Okay, let us find the next one. What is that? Magnitude of the maximum shear stress. What is the magnitude? Here, this is the formula to find the magnitude of the maximum shear stress. That is plus or minus sigma x divided by 2 whole square plus tau square xy. Okay, substitute. What is sigma x? Sigma x is equal to 150 divided by 2 plus tau square xy. Tau xy is minus 50, so square. Simplify this, you get plus or minus 90.14. Okay, so now let us consider theta x is equal to angle which plane of maximum shear stress makes with the x axis. So we have to write this tan 2 theta s, that is equal to sigma x divided by 2 into tau xy. This formula you remember, okay, it is always same. Tan 2 theta s is equal to sigma x divided by 2 into tau xy. What is sigma x? 150 into 2 into 50. Simplify this, you get simplify. So 2 theta s is equal to tan inverse of 1.5. So tan inverse of 1.5, you get 56.3. Okay, we want theta, so theta s is equal to 56.3 divided by 2. So that is equal to 28.15. So this is the direction of the shear stress. Okay, this way you can calculate what is the magnitude and the direction of the shear stress. Here only you have to remember the magnitude of the maximum stress is equal to sigma x divided sigma x by 2 whole square plus tau square xy. Substitute, you get then tan 2 theta s is equal to sigma x divided by 2 into tau xy. Okay, simplify this, you get 1.5. So 2 theta s is equal to, simplify this, tan inverse of 1.5, that is equal to 56.3. Okay, so theta s is equal to 56.3 divided by 2, that is equal to 28.15 degree. Okay, so like this you can calculate. Okay, let us take one more example. This you try and you just note down this problem. An element in the strain body is subjected to a compressive stress of 200 MPa and clockwise shear stress of 50 MPa on the same plane. Calculate the values of normal and shear stress on the plane inclined at 35 degree with the compressive stress. Also calculate the value of maximum shear stress in the element. Okay, solve this. We will discuss in the class. Okay, hope all of you understood. If you have any difficulties, we'll discuss in the class. Okay, thank you.